So where we left off in Unit 5 was on factoring, and we had worked all the way up to factoring trinomials. But before we left, we were factoring trinomials where the a value was always 1. So we were not doing anything that had a number right here. So what we're actually going to start doing this week is looking at what happens when there is actually something other than a 1 in front of the x squared term. So these are the steps. Those of you who received it before we left, you guys have a packet that has all of these problems in it. If you were absent before we left, then you don't have the packet. So what you need to do is pause the video, grab a notebook or some blank paper where you're going to write down your notes and go through these problems with me now. So when we're looking at a problem like this, notice we have a 6 in front of the x squared. So the only thing we are changing about the process of what we were doing before is instead of only looking at the factors of 2, we actually have to take 6 times 2. So we are going to multiply 6 times 2, and we get a 12. So remember, when we do trinomials, we always think x box, right? So our x is asking ourselves what numbers multiply to 12 that add up to 7. So again, the only thing we're changing is instead of just looking at the factors of a 2, we're looking at the factors of a 6 times 2. So 6 times 2 is 12. And if I actually started to list out my factors, I would say, okay, 1 times 12. I could say 2 times 6. I could say 3 times 4. So we're looking for the same set of numbers that when I multiply, and here we'll just make that multiply, we get a 12. When we add, we get a 7. So of my list, it's the 3 and the 4. So 3 times 4 multiplies to 12, and 3 plus 4 adds to 7. So that's the winning combination that we then fill into our box. So also remember some of the easy things about our box. How we fill in this first box and this last box is always the same. It's always from the first term and the last term. What we do with these two numbers we just came up with is we fill them in. So plus 3x plus 4x. And now we're right back to where we left off in this unit. So 6x squared and a 3x, if I thought to myself, what could I factor from these? Well, the greatest common factor of a 6x squared and a 3x is a 3x. The greatest common factor of a 4x and a 2 is a plus 2. Greatest common factor of a 6x squared and a 4x is a 2x. And the greatest common factor of a 3x and a 2, well, those actually have nothing except a 1. So we have to put a 1. So that is my answer. This factors to be 3x plus 2 and a 2x plus 1. Now, go ahead and write down the word check, because I'm going to show you two different ways to check these answers. So we have a 3x plus 2 and a 2x plus 1. So 3x plus 2 and a 2x plus 1. So when we go to check these, we can actually use FOIL, which I bet you guys remember hearing in Algebra 1. So when we FOIL, we're going to take the first. So the first means the first terms, which is the 3x and the 2x, and you get a 6x squared. Then the O tells you to do the outers. So when I do the outers, I'm going to have a 3x and a 1. And that's going to be plus 3x. The inners are those inside terms, and that's going to be the 2 and the 2x, which is 4x. And then we do the last, which are the 2 and the 1, and we get a 2. And so then you just look to see what like terms you can combine. And these combine to give you 7x, and we get the same thing we had started with, 6x squared plus 7x plus 2. That's how you check using FOIL. The second way to check is to just write out your box method and do exactly what we had just reversed when we factored and just see if it still works. So we write 3x plus 2 on one part, and we write 2x plus 1 here, and we make sure it works. So when I do 3x times 2x, I get 6x squared. When I do 2x times a 2, I get plus 4x. When I do 3x times a 1, I get 3x. And 1 times 2 is 2. And then you look for your like terms, which in the box method is nice because they're usually right there on the diagonal. And I get a 6x squared plus 7x plus 2. So notice here, it works, it works. We don't expect you to do both of these. You can pick the one you prefer. So when you see the word check, I want to see this, FOIL, or the box method, not both. So let's see if we can do another one. So, big idea here. The only thing we are changing about what we were doing before is instead of just looking at the 4, or the negative 4 in this case, you have to take 6 times negative 4, and that's where we get that negative 24. So now the question is, there has to be two numbers that multiply to give me negative 24, and those exact same numbers have to also add to give me negative 5. So most of us have to kind of go through this process. Negative 1 times 24, negative 2 times 12, negative 3 times 8. So as I'm looking, negative 1 and 24, that's going to give me 23. Negative 2 and 12, that's going to add up to 10. When I do a negative 3 plus 8, I'm going to get a positive 5. I need a negative 5. So all I have to do there is change those signs. So what I actually just found here are the winning numbers. A negative 8 times 3 gives me negative 24. A negative 8 plus 3 gives me a negative 5. So that tells me our winning combination. So just like when we were doing our other trinomials, remember, these two are always from the first term and the last term. There is zero work involved with how you fill in this box and this box. Where we have to put our thoughts and work into is figuring out how to fill in this box and this box, which is why we go through this process with the x over here. Now we do what we had actually started with in this unit, and we think about GCFs. So 6x squared minus 8x. I'm going to take from that, I can divide a 6 and an 8 by a 2. From an x squared and an x, I get to take an x. When I do 3x minus 4, well, there's actually nothing except for a 1. And then we do the same thing with the column. So 6x squared and a 3x. I can actually divide a 6 and a 3 by a 3, and then an x gets to come out. And then here, a negative 8 and a negative 4, I get to take out negative 4. So my answer here is a 2x plus 1 times 3x minus 4. When I check this, I'm going to go ahead and write out FOIL this time. All right. So when I FOIL, we kind of draw out our little arrows. So 2x times 3x is 6x squared. That's good. All right. Then I would have a 2x times a negative 4, which gives me negative 8x. I'm not going to see that over in the original problem yet. A 1 times a 3x is a 3x. And then a 1 times a negative 4 gives me negative 4. When I combine my like terms, I get the negative 5x that I had in the middle, and then we had the negative 4 there at the end. So that shows me that it works. Okay. All right, so I'm going to go through one more with you, and I'm just going to do this one a little bit faster, but from scratch. So remember, 2 times -3 gives me -6. This middle term is always what goes at the bottom. So the question we have for ourselves, what two numbers multiply to give me -6? That would add up to give me 5. So factors of -6, 1 and -6, -1 and 6, -2 and +3, or -3 and +2. Of my choices, this is the winner. A -1 times a 6 and a -1 plus a 6 works in both. So now I have the winning combination. So how to make all of this fit in our box? Remember, the 2x squared always goes in the first spot. The -3 always goes in the last spot. These two numbers I just came up with is how I fill in the diagonal here. So then I go through. A 2x squared minus 1x, well, that only has an x in common. If you want to write a 1 here, you can. 6x minus 3 has a 3 in common. 2x squared plus 6x has a 2x in common. And then all I see here is a -1. And that is my answer, 2x minus 1, x plus 3. Now, we do check just because we want to make sure we have the right answer. So when I check this, I'm going to have 2x squared, and then I have a plus 6x minus 1x, and last but not least, minus 3. And when I compare that with the original problem, I get 2x squared plus 5x minus 3. And we have the right answer. So now what you need to do is check Canvas, and where this video is posted, you're going to find an assignment that I want you to do to make sure that you can try some of these problems on your own.